Well, hello everybody. Um, Today I'm going to do a little bit of technical thing. So this might not be for everybody. Let me know in the comments if you like this or you dislike this. But we're on this journey to create a toy company, and most of what happened in the development side, uh, you weren't part of. You didn't see. But today we are actually going back to a little bit of development work. So I'm going to show some technical things. I'm not going to talk too technical. I'm just going to kind of try and explain what I'm doing, what the problem is. So we decided we were going to add a new memory chip inside the unit, and I have my new circuit boards. We've managed to put a chip onto the old board and get it working. We can write data to it. We can read it off. Now we need to make a memory system. Okay, how how do we do this? So there's an interesting question. So, oh no, I've started making a video and a fly's just come in, just buzzed around me. Right, okay, let's move Truman over for a second. The way the system works and the way electronics works is we have a what we call the central processing unit, or it's the main chip, right? The main processor. And then inside the cartridge, we have it's called a memory chip. And the way it works is a data line comes out and goes in, and then it goes into the memory chip in the cartridge, and then it comes out and goes back to the central processor. And it says, send me this data, and then data comes back. Now, the nice thing about these particular memory chips is you can daisy chain them. So you can put a second one on, and the data goes in, put another memory, and then it comes out and goes to the next one. But how the processor needs to tell the chip which chip it wants the data from. And it does that. It has if you think of the microchips, like little black squares, and they've got these little silver legs, and you put voltage on one of the legs, and that means that that chip is selected. And it's actually called chip select. So the processor has another cable that goes up to that one and says, select that chip. Or it has another one that goes to this one and says, select that chip. And when I built the unit, I was using all of the connections. I didn't have any extra connections for this chip select. And then I realized that when I was developing it, I was using some connectors to connect to USB to send data back to the computer. So as I was coding it, I could see what was happening inside the unit itself. So the idea now is we're going to have one memory chip which will be inside the cartridge, and another memory chip which will be inside the unit. And we're using the diagnostic lines for the chip select. So we've managed to just squeeze this little bit extra out of it. So how do we do it? How do we actually make this work? Well, there's an easy way and a hard way. And you know what? We're doing it the hard way. So the way I could do this is the memory chip is for each game would have a particular, like an ID number, like a serial number. And inside the memory chip, you can imagine we make lots of save slots. And if the game has ID number 1, it writes there. If it's ID number 2, it writes in there. If it's ID number 3, it writes in there, ID number 4, and so on. And it will be very simple. And we've got space on there for 7,000 game slots. So 7,000 save slots. So to put that into context, the PlayStation 1, there was only 4,000 games released. But that's a huge amount of games. So I could easily put all of the save data for the entire PlayStation 1 catalog on this. But what I really want to do is I want to have an instruction that says, has this game ever been inserted? Does this exist? So how I'm going to do it is on top of that, we'll have a smaller version that we'll call a table of contents. So if you've got a game and you put it into the unit and the game has an ID number that says game number 15, we say, okay, we'll write game number 15 there, This is now game number 15, so we can mark them 1, 2, 3, 4 the same way. And then if you put another game in, let's say game number 156, that will be written on the next one. And then slot number 2 will be called 156. So it has a table of contents. Far more complicated. But I'm kind of looking forward to writing the code for this, to actually write the firmware, because it's a nice challenge. It's I'm one of those strange people that really enjoys coding. You know, most people think it's this terrible, oh, I can't stand it, I hate it. I just go into Zen mode. I just sit there like this, and then I look at the clock and it's 4 o'clock in the morning, but I'm really happy. I kind of get in my zone for that. So this is what we're going to do. We're going to, first of all, we need to hand build a new board, and this is a bit tricky because the boards really need to be assembled by a machine, but I need to do it by hand. So that's the next thing. We're going to build the board, we're going to write the firmware, and we're going to test everything and make sure it works.